Hello and welcome to another lecture. In this lecture, we're going to go ahead and design a column. This one is going to be with intermediate bracing, as you can see here. Let's take a look at this plan view right here. We're going to design this center column right there, and the base size are about 50 by 50. So the tributary area for this column is about 250 square. Let's say the dead load, let's calculate the dead load being 6-inch lightweight concrete, 112 pound per cubic feet. So that would be 112 times 6 divided by 12. So the dead load is about 56 pound per square foot. That's dead load. And let's give it a live load of 168 pound per square foot, and therefore my dead load PD is going to be let me shut this up so you can see it better. 6 times 2,500 square feet, and that gives me about 140,000 pound or 140 kip. And live load is going to be 168 times 2,500 square feet, and that gives me about 420 kips. So our load is going to be right here. PD was 140, and live load is 420 kip. And then one thing we're gonna do, so if you experienced designer, you automatically say, okay, I'm going to use W14 by 100 by this or that. But if you haven't done this and you need to pick, or you don't know what to pick, normally W12 or W14 or W16, around that area, it's a good size to pick based on, sometimes the architect might let you know. So let's say we're going to use W14, but we don't know what size, and then we pick a size. We're going to guess at the size, and then we're going to come back and do the analysis on it. And the way we're going to do that, we're going to assume, let me write this down here. Let's assume LC over R ratio of anywhere from 40 to 60 is good. Let's just use 45 for now. And then we're going to go to table 414. Okay, let's go there. Okay, this is table 414. If we go to right here, there is the LC over R right there at the top, and then we said let's guess at 45 right there, and the steel is gonna be FY50, so I'm gonna come across FY50. Let's use I used 38.5, but that's okay. That is 46, that's fine too. So let's use phi C times Fn of 38.5. Phi times Fn came out to be, use 46 here actually, 38.5 KSI. And then let's find required area, and that's going to be PU divided by phi times Fn, and our Pu, we don't know that, so let's do a Pu. Pu is equal 1.2 times 140 plus 1.6 times 420, and Pu comes out to be 840 kips. So I'm going to have here 840 kips divided by 38.5, and that will give me 21.8 inch square. So now we're going to go ahead and go to table 1.1 for W14. Look for an area. Let's do that. So here is table 1.1, and we're looking at W14, and we look at the area. Our area was 21.8. So I'm going to come down. W14, 21, right there. 21 point is W14 by 74. We don't want to pick exactly. You want to pick something 1 or 2 higher. I wouldn't even go 24. I probably go either W14 by 90 or W14 by 99. I pick from this group. Any from this group is good. So let's just pick the lowest one. Let's say pick W14 by 90 with the area is 26.5. Okay, W14 by 90. We picked that one up. One of the things we're going to do now, we're going to calculate, look at the column. Effective length. And that is basically because it's a pin on both ends, our K is equal 1, and you can get that from table CA 7.1. You've seen this many times, so I'm not going to even show you that. And now we can go ahead and look at the LCY, because the table 4.8 is based on weaker axis, which is Y. So now it's KY times LY, and remember it's braced at the weak section, so it's if you look at the column right here, it's braced at the Y axis right here. It says right there, and therefore the unbraced length is right here, is this much right there, and which is a 15 feet. But if you look at the X axis, the unbraced length will be right here, which is equal 30 feet. So let me come back in here. We're gonna say, okay, 1 times 15 is equal 15 feet. But we're gonna look at the X direction, which is 1 by 30, right? However, there is no, in table 4.1a, it doesn't have buckling in the X direction. Table, let me just write this down so you can see it too. LCX is equal K times LX, which is equal 1 times 30, and that's 30 feet. However, remember, let's go to the table 4.1a for a second. 4.1a, where was it? Table 4.1a, that is for W10. Let's go to W14. Okay, we're looking at W14, and W14 by 90 is the one way up here. All right, and you can see right here, and this right here, it says RY. Okay, this is based on L. Read this, and the LC is based on a Y direction, so there's no X. Therefore, we have to convert it to Y. To do that, we're going to come back at the bottom of the page for right here. Come down right there, right here. And if you go right there, you have Rx divided by Ry, and is 166. Our Rx divided by Ry, it was I think it was 166. Yes, it was 1.66. So therefore, if we look at the equivalent, LCY equivalent is equal LCX divided by Rx divided by Ry, so which is equal 30 divided by 1.66, and that's equal 18.1, which is bigger than a 15, so this will control. Okay, I'm going to use not 8, I'm going to be conservative, so I'm going to say LC is equal 19, because 18.1, just go to the next one, 19, and it's easier to find in a table. So now let's go to table 41A with LC is equal 19, and we're going to find phi PN. Let's look at it, see if we can find it for LC equal 19. Okay, 19 is right there, going across for W by 90, and I find phi C times PN is equal 903. Okay, so I'm going to come back here. Phi C PN is equal 903 kips, which is bigger than our 840 kips, and that's good. That's it, we're done, and it passed. That's how you do it. Okay, this was a good one. Hope you liked it. Give it a thumbs up if you do.